All right, so let's kick it up a notch here. In the previous problems, we were looking at inequalities with just one variable, variable x. Now we want to consider a system of inequalities. So we have two variables now, x and y. So we have two inequalities that we're going to focus on, all right? The first one is y is greater than or equal to 2x squared plus 5x minus 3. And the second one is y is less than x squared plus 4x plus 3. So the same two equations that we've been dealing with, but now we're looking at a system of inequalities. We already kind of discussed which graph represents which equation, so I'm going to just highlight those to correspond. So just so we have an idea of which parabola represents, or which equation represents each parabola. Now we're going to do a couple of things here. So I'm going to just use a gray highlighter here, highlighting tool, marker, whatever you want to call it. And I'm going to shade everything that is above this first equation. So everything that's above the pink equation, all right? So that would be things that are greater than or equal to the 2x squared plus 5x minus 3. So that's everything above all of this. So it would include all of this. I'm going to just go right over that gray or blue. So this is everything above that graph. Okay, next we're going to shade, and I'm going to just use a marker this time to kind of shade in this area. We're going to shade everything that is below the blue graph. And the reason I'm doing that is because we have a less than symbol there. So we want all the values that are less than the blue graph. So that's going to be, and I'm just going to use kind of a different shading technique here, because what I want to do is be able to find all of the points that are shaded twice. So what that ends up being is this section right here. I'm going to just highlight it in yellow. Okay, so let's look at identifying whether or not these 3 points are actually going to be solutions to that system. So in order for it to be a solution to the system, it has to lie in that area that I shaded in yellow. So negative 3, 0. Okay, here's the thing. Negative 3, 0 is on the pink boundary, which is interesting because that would make this equation true. Watch, if I plug in 0 for y and negative 3 for x, okay, I'm going to get 0 is greater than or equal to 18 minus 15 minus 3. So 0 is greater than or equal to 0. That's a true statement. 0 is equal to 0. So I know that it works for the pink graph. But if I try to plug in the point negative 3, 0 into the blue graph, watch, I get 0 is less than negative 3 squared plus 4 times negative 3 plus 3. I get 0 less than 9 minus 12 plus 3. I get 0 is less than 0. This is not true. Okay, so it doesn't work for the blue graph. So what this tells me is that if I have a less than or equal to sign or greater than or equal to sign, and the ordered pair is on the curve, it'll satisfy that inequality. But if the ordered pair is not, if your inequality is just less than or just equal to, and the ordered pair is on the curve, that ordered pair will not satisfy that inequality. Okay, so we have to be really careful there. So negative 3, 0, no, that does not work. All right, negative 1, 1. Well, negative 1, 1 is going to be like up here. That's not in that area that's shaded twice. It's not in that yellow region, which means it's not going to satisfy both inequalities, okay? It is not both greater than the pink curve and less than the blue curve. It is just greater than the pink curve. And then finally, 1, 5. So 1, 5 is like right here. Now, that is in that yellow region. It's greater than the pink curve and less than the blue curve, which means it actually does work for that system. So that is the only one that will work. So how are the solutions to a system of inequalities like we just graphed different from a solution to just an inequality with one variable? And that's the big difference. The inequality with one variable, we're only concerned about getting solutions that are in terms of x. But as soon as we get a system like we have on this slide, we have both x's and y's, which means that our solutions have to contain both x's and y's. So our solutions are ordered pairs, and that's why we have to look at a shaded region on the graph. In both of our solutions, we were able to do some shading on either a number plane or a coordinate plane. A number plane works when we have just a single variable, but we need to look at a coordinate plane when we have two variables because now we're looking at two dimensions.